Welcome students, myself PS Bakshi. Today we are going to discuss a topic of mass and pulley system problems. This topic can resolve many numerical problems of mass and pulley system. It's going to be very easy topic, but if the student is having a concept knowledge, full concept knowledge of this topic, so I will help you to have the concept knowledge of that topic, okay? So this topic is in chapter 6 or unit 3rd, which is known as laws of motion. Now, some assumptions are also taken in this topic because we are not having a frictionless pulley, obviously, but we take a frictionless pulley in this topic, and also the string is inextensible, which means it's not elastic. We are neglecting the elastic properties of the string. So first of all, we are going to have a frictionless pulley. Now assume that is our frictionless pulley and that is the center O of that pulley. Now two masses are attached on that pulley with an inextensible string. So let's assume the masses are, so that is mass small m and the extension is just like that, and we are having a capital mass m here, okay? So obviously that mass is bigger than the smaller mass, which means we are assuming that capital M is greater than small m. So we are having two masses now where capital M is greater than the small m. Now, how we can make a free body diagram out of that? If you are able to make a free body diagram of any mass pulley system, which means the directions of tension, the directions of accelerations, the directions of weight, then you can easily solve that topic, okay? So what we are going to solve here, we are going to make a formula for acceleration, and we are also going to make a formula for tension in the string. If those formulas in your formula list and you are now able to understand that topic well, then you can solve any numerical problem of mass pulley system. So this topic is very important because if we are taking a point of view of IIT, JEE and NEET, okay, also the bit set, okay, so focus on that. So that is a smaller mass, that is a capital bigger mass, you can capital M, which is taken as a symbol of that. Now first of all, the tension of the string is always going to be toward the pulley center, so which means the tension is always going to be toward the pulley. So that is always going to be your direction of that, how you can make the directions of tension. Obviously the weight is going to be downward here, so this is going to be mg, and weight is also going to be downward here, that is going to be capital Mg, because weight is also we take a gravity under consideration as well, so which means you all know weight is equal to mg, so the weight is always going to be downward in this direction. Now you have clearly seen that the bigger mass system is always going to be in downward direction, which means that system is going downward. That system is going downward with the acceleration a. And similarly, that system is moving upward with a similar acceleration a. That is how you are going to make a free body diagram. Now, this diagram is now very simple. We have just mentioned the tension in the strings, and we have just put up the downward weight options of both the weights, okay, both the masses you can take. So now that system is moving downward, so we have taken acceleration in the downward direction. That system is moving with similar upward acceleration, so that is why I have a direction upward for smaller mass. So that is going to be the construction of diagram as well. You have to write few words about the construction as well. So I'm just going for the main topic here. Now here two assumptions should be taken, and you should write those assumptions. First is that is a frictionless pulley. That is a frictionless pulley, and the string is inextensible. You should always write those assumptions, because if we are going to consider the friction of the pulley now, then that formula is not going to be true for that. Okay, and obviously if you are going to consider some elastic properties of the string, then we are not able to find the formula so easily. So those are the assumptions in the mass pulley system. Now, first of all, we are going to make equation of motion of the bigger mass. So equation of motion of capital M. Now, how we are going to make a equation of motion of the bigger mass, that is taken as capital M. Now, you have to think about that thing, the system is moving in which direction. Now, that is a bigger mass, so the system is moving in downward direction. So which means mg is greater than the tension T. That is clearly seen here. So mg, capital mg is greater than tension T. That is why the system is, you can easily put up that the system is moving downward. You have to write that downward. Okay, now therefore the net force is going to be equal to, now net force responsible for downward motion is, so that is F is equal to, yes, mg minus T, because mg is greater than T. Now you all know what is F is all about, because F is going to be equal to ma, so therefore ma is equal to mg minus T, equation number 1. Now the net force is going to be the resultant force of these two, because mg is greater than the tension T, that is why we have taken mg minus T. So net force can be written as ma, because F is equal to ma, that is Newton's second law. So ma is equal to mg minus T, so that should be taken as equation number 1. Now similarly, you can have net force for smaller m. So net force for smaller m is going to be, because the system is moving in upward direction. Now that is the equation of motion of smaller m. Now that is going to be, similarly we can solve that too. So that is going to be, yes, so F is going to be equal to, yes, now T is greater than mg. Now why T is greater than mg? We have taken a small m here, we should take a small m here, because the system is moving in upward direction, which means T is greater than the smaller mg. Okay, so which means the net force is going to be equal to, yes, so that is T minus mg, and you all know, so force is going to be smaller ma, which means ma is equal to T minus mg. That should be taken as equation number 2. It is very easy. Now what is the difference between these two? The system is moving downward, that is why capital mg is greater than T, so therefore net force is mg minus T. Now the system is moving in upward direction, that is why T is greater than smaller mg, that is why T minus mg. Now you can put up the value of F easily. Now adding those equations, you can have the value of acceleration. So just adding equation 1 and 2, you have the answer. So which means ma plus smaller ma is equal to, yes, mg minus T, yes, plus T minus mg. So which means T is going to cancel out here. Now you can take a common here, that is capital M plus small m, and that is going to be, yes, you can take g common here, so m minus small m into g, and that is your answer. So A is going to be equal to capital M minus small m g over capital M plus small m. Now that is going to be your answer for acceleration. That is so easily we can solve that mass pulley system. Now, how you can calculate the value of tension T? You can just put up that value of acceleration in equation 1 or equation 2. You can have the answer. So it's going to be very easy topic. How you can calculate acceleration? Just adding equation 1 and 2, and after that the value of A can be put up in equation 1 or 2. You can have the value of T. So I am solving it here. I am just erasing that diagram because the function of diagram is now finished. So I am just erasing that to understand it properly, how we can calculate that. From that equation, adding equation 1 and 2, we have the value of A now. The value of A is, yes, M, capital M minus small m is going to be equal to capital M plus small m into G. That should be marked as equation number 3. Now you can put up that value in equation 1. So therefore, equation 1 becomes, so we are using the value of A in equation 1, which means M, yes. Now I am putting the value of A here, so which is going to be, yes, M minus small m plus small m into G is equal to, yes, mg minus T. Now you can easily calculate the value of T from here. So the T is going to be equal to, yes, mg minus m. Yes, you can easily go through that. It's very easy. You can just solve it mathematically. So that is going to be, yes, mg. So that is going to be mg. So how you can solve this easily? So this is going to be very easy topic right now. I have just shifted T here and put up that value here. So this is going to be now, yes, so minus m plus smaller m and minus m minus small m into G. So we are just solving it mathematically, just opening those brackets. That is m square G, that is m smaller m G, that is minus m square G and plus capital M small m G over capital M plus small m. Now m square G is cancelled out, and what you have in the answer, so that is 2 capital M small m over m plus m multiplied by G. Now that is going to be the value of tension T in the string, and that is the value of acceleration. So these two are the basic formulas for any mass pulley system. If you are going to solve these acceleration and tension T formulas, if you have those formulas in mind and how these formulas are derived, you can easily solve so many numerical problems of mass pulley system. So hope you have understand that. If you understand that, so like our video and subscribe our channel, and thank you so much for watching that video. Thank you so much.